Yes, did you send me an email?
Yes, sir. And I have given you a minute.
But okay, I got it. Uh, okay, in that case, you have to send me the answer script to my email by 12:50. Okay.
Okay, sir.
Okay, the assignment is sent to your email. Check.
Okay, sir.
Okay, I think most of you have submitted already, right? It's over 12:50. After 1 p.m., no submission will be allowed. So please submit. Those who are still to submit, please submit your script as early as possible. Only 19 submitted. I think many of you not yet submitted. Please submit as early as possible. We will start the class. Please submit. We will start the class. One problem I am facing in ELMS right now, you can submit, there is no problem, but your answer scripts are not directly opening. Maybe some problem there, so I have to download and then check. Currently, I cannot open directly in ELMS, so that is a problem. So I think since I cannot see your answer scripts right now, I will check later. So right now I will not take any Viva today, but maybe later. Your answer scripts are not opening directly in ELMS. Anyways, please. Why? What is the problem? It's not loading. ELMS. Okay, who else are facing the same problem? Try. You can try up to 1 p.m. Okay.
স্যার এই ক্ষেত্রে একটা কাজ করতে পারেন স্যার, ওদেরকে স্যার একটা মেইলে সাবমিট করে একটা সুযোগ দিতে পারেন স্যার।
জি স্যার।
After 1 p.m.
Okay sir.
আচ্ছা স্যার।
Because until 1 p.m. you can try, because if you send too many answer scripts to my mail, that will be again a problem. But only so far only 24 submitted out of 57 students. Almost 50% yet to submit. 3 minutes left for ELMS. $26, $40. Please submit. Please try. It will accept submission until 1 p.m. Try up to 1 p.m. because up to 1 p.m. it will accept. 28 submitted. Oh no. Still 2 minutes. Please try. Oh, what is the problem? Fifty-one. 32. I think 12 or 13 yet to submit.
স্যার
Yes.
স্যার আমার মেলটা গিয়েছে কিনা একটু দেখবেন, মেইলে প্রবলেম হচ্ছে স্যার।
আপনাকে কি মেল করবো স্যার? এটা তো হচ্ছে না।
লোডিং হচ্ছে স্যার বারবার।
আর এখনো লোডিং হচ্ছে।
Okay, now I think it's already 1 p.m. So you have to send me through email. Okay. Send me through email. Those who are yet to upload, send me through email. Okay. Khushida, did you send me answer script? Khushida Jahan.
স্যার ওর নাকি কারেন্ট চলে গিয়েছে।
Oh. Okay, anyway, those failed to upload, please send me through email. I will check later. But it's still, I think, 34 submitted through ELMS. So others, please send me through email. Also, your PDFs are not directly opening in ELMS. I will solve that.
স্যার
But yes,
স্যার টু পাঠাইতে পারতেছি না মানে কোনোভাবেই।
Email?
ইমেইলে
you cannot send through email.
না স্যার।
Okay, try, because there is no other solution. Try sending email.
স্যার মেবি গিয়েছে কিনা একটু দেখবেন।
No, I didn't receive. I received from Taki Yasir.
স্যার দিস ইজ এম ইয়াসির আরাফাত।
Yasir, no, Yasir Arafat. I did not receive yet. Did you send that? It
স্যার ভিপিএন ইউজ করে সেন্ড করলে হচ্ছে।
Oh man, that is the problem.
কোনো
Why
কিছু
that
ছিল
should-
না। জি স্যার, এখন ভিপিএন
Why that should be a problem? Email should not be. Yasir Arafat. Yes, I received. I have received your answer script.
Okay, sir. Thank you.
Taki Yasir, Yasir Arafat.
স্যার আমারটা পেয়েছেন ইমেল করেছি এখন
Okay, yes, Fazila, I have received your answer script. Khandokar Jahidul received. But please, those who have already uploaded ELMS, don't send me email. Okay, 34 already uploaded in ELMS. So the rest send me through email. Shalom, yes, I have received.
স্যার আমারটা পেয়েছেন স্যার
Who is talking?
স্বামী আহমেদ স্যার
Samir Ahmed, not yet. Yes, Samir, yes, I got your one. Abrar Sadiq, I got your answer. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I got 7 answer scripts through email. Okay. Anyone else yet to send email? Because there are 43. So
Sir,
24
আমি
plus 7. Tahmina, just send.
ইয়েস স্যার স্যার মেলেও
email.
যাচ্ছে না আমি বুঝতে পারতেছি না কেন
Okay, try, no problem. It will, don't panic. It will go, no problem. It will work. Just try sending. It might take some time. Maybe network is slow, that's why. Okay, let us start the class. Okay, how was the question? Is it okay? Everybody, now you have clear idea about email and DNS. Okay, so I think we have finished chapter 2. We need to start chapter 3. Okay. Let me start the class. Though those yet to send email, try sending me email by the end of the class at least. Is it the network problem now? Messenger was not working.
Yes, sir. Network is very much troubling.
স্যার
Server
নেটওয়ার্ক
down.
প্রবলেম আবার ইলেকট্রিসিটি নাই এখানে স্যার বিচ্ছির একটা অবস্থা স্যার
Oh, okay.
স্যার
Maybe
সবকিছু
one-
বন্ধ করে
one or-
রাখছে স্যার।
Maybe 1 or 2 more days we have to bear this pain.
ইয়েস
জি স্যার এই উইকটা একটু খারাপ যাচ্ছে
সব ওয়েবসাইট স্যার
Even some internet servers are stopped working.
Yes. Okay. We have to live with that. No way. Fine. This is a class assignment. Don't worry. But what I want you understand. So maybe next time I'll take some individual viva, maybe without written. Okay, so for today, I think let us start chapter 3 because we are a little bit behind the schedule. According to our class. But in the midterm week there will be classes, right? So we'll have maybe two more classes to cover up. That's why I am going slow. Don't worry. I am just giving you time to adjust. Those who are yet to actually pace with the class, still you have some time. I am going very slow, but we have to cover up our syllabus by the end of the trimester. So maybe I will go a little bit faster from now on. So please try to be attentive in the class, try to adapt, and when I give any classwork other than class assignment, anything I give you in the class, please try to do with paper and pencil. In that case, your pressure of reading at home will reduce. Okay, so let us cooperate
আপনি যে
each
ক্লাস
other.
স্যার হোম অ্যাসাইনমেন্ট দিচ্ছেন এটার কি টাইম কি স্যার একটু বাড়ানো যাবে?
What is the deadline? 28 today.
No, sir, 31st.
30, I think 3 more days. See, all the questions are solved in the class. Even in today's class assignment 1, all the questions are solved in the class, right? Anybody disagree? No, you just you have also it was, I think, uploaded last Monday, right? So you have 10 days. I suggest you to do start early. Just if you start today or tomorrow, that will be a big problem. Even if I increase 3 more days, someone will start on 31st March. So that's why normally I don't change, because I am giving you enough time. So you can also, number of questions are not that many. Most of the questions you have solved in the class, so you have already the solution. Just maybe 2 or 3 hours you have to accommodate to find the solution. So 3 more days, I think it should be enough. Anyways, let us start.
একটা বিষয় জানার ছিল, সেটা হচ্ছে আমাদের ফাইনাল সিলেবাস কি স্যার নেক্সট উইক থেকে শুরু হবে?
Okay, good question, very good question. Actually, I didn't think about that. Let me think about that, but don't worry, it should be manageable to you. I will put something bearable for you. Just
thank you, sir.
Just don't worry about that much. Maybe what I will do, I will maybe reduce some sections. I will include the most important sections, because see, in the class assignment we did not cover HTTP, but we have covered HTTP in homework 2. But that is also an important protocol. So during the final syllabus, I think one way can be just reducing sections, and most important sections will be included. Another way can be in terms of chapter wise. I will inform you, I think well ahead before the final exam, don't worry. Okay, so we'll start chapter 3 today, and the sections we will cover is 3.1 to 3.5 and section 3.7. So this is transport layer. We have completed application layer, and we know that now we know that application layer is dependent on transport layer services. So we have a little bit of idea what kind of services transport layer provides, right? And there are how many types of services transport layer provides? Anyone? Transport layer provides services to application layer. How many types of services? 2 types, right? One is reliable, one is unreliable, right?
Sir, reliable TCP বুঝায়?
Right. All reliable applications must use TCP, because TCP provides reliable service. How TCP provides reliable service? That is the content of chapter 3. In chapter 2, we had the basic idea of reliable, unreliable, and we knew that TCP provides reliable service. We had some basic idea about the services by TCP. For example, it will send the feedback acknowledgement, then it will do the flow control, it will do the congestion control. Okay, and UDP, it will work faster, so it will not send any feedback, and there are many other reasons why UDP works faster. But how? So chapter 3 will enable us to know the detailed mechanism, but in chapter 2 we already have idea that transport layer gives services to application, so application layer depends on transport layer services. Now, what are the goals of this chapter? Understand the principles behind transport layer services. Okay, multiplexing, demultiplexing, reliable data transfer, flow control, congestion control. And also we will learn about the Internet Transport Layer protocol. So in Internet, we know there are two protocols provided by Transport Layer. One is TCP, that is Connection Oriented Reliable Transport, and one is UDP, that is Connectionless Transport. Because in UDP, there is no need to establish a connection. And in chapter 2, we have already seen for non-persistent, persistent HTTP, we have to establish a TCP connection. For email that uses TCP, we have to establish a TCP connection. So that means this will take some time. But in case of UDP, there is no connection. So that's why it is connectionless. That is one reason why it is faster. And also in Internet, a very important concept is congestion control. If there are so many users sending much more data, then sometimes what might happen, the demand of services maybe will be over the capacity. So in that case, what will happen, like traffic jam in our roads, when more and more vehicles come, then the capacity of the road, then actually traffic jam happens. So similar here, we will read that in section 3.7. Now section 3.1, similar to the other chapters, first section will be the review of actually the layering concepts, because in layering models we have already covered what is the basic functionality of transport layer, what are the basic responsibilities of transport layer. So in the start of every chapter, we will just review that concept. So here again, we will review about transport services and protocols, and the same diagram we will use throughout the entire trimester. You can see in the diagram, previously we were thinking about application layer protocols, and we said application layer works at the network edge, and that means application layer will work in the end systems. One similarity of transport layer with application layer is still in transport layer, you can see the transport layer will also work in end systems. So there will be no transport layer in the intermediate devices. So still we are in the end systems. And between transport layer, there is a logical end-to-end transport. So it is called logical end-to-end because transport layer creates a logical connectivity between two application programs, right? Like web browser to web server. Whenever we use a browser, that browser actually works on top of transport layer, and it communicates with the web server in the destination machine, destination server, that also works on top of transport layer. So transport layer basically connects two different application processes running on different physical machines. Is it clear? So that is the first thing you have to understand the detailed mechanisms. In the router, there is no transport layer. Okay, now transport layer works at end systems. That is already we have understood. But for any kind of communication, there is a sender, there is a receiver. So what is happening at the sender side? It takes data from application layer. See, the same layering concept. Takes data from application layer, breaks into a number of manageable segments, and passes each segment one at a time through the network layer. So that is what the sender machine, sender end system do. And also another thing is the lower layer under transport layer is what? Network layer. As we said, lower layer gives services to upper layer. So network layer will give service to transport layer. How? It will receive a single segment at a time, and it will decide the path, best path through which that particular segment will be carried to the destination. So transport layer works on top of network layer service. Okay, but transport layer will not deal with data link and physical. Now in the receiving end, receiver will receive one segment at a time From which layer? Anybody? On the receiving side,
So
receiver.
network layer.
Very good. From the network layer. So network layer will carry that particular segment and will hand over to the transport layer at the destination. Same idea. But network layer will deal with only one segment at a time. But transport layer will deal with all the segments it got from the application layer data. So suppose there are 100 segments from the application layer, 100 segments created. It will send through network layer one segment at a time, but it will ensure all 100 segments have been transferred to the receiving transport layer. So if some segments are lost, then receiving transport layer will send the feedback, as we know from the layering concept already, and the sender transport layer will retransmit all those segments. Now in this chapter we will go in depth to know how that mechanism is implemented, but that is how the receiver will receive all the segments. It will reassemble the segments to produce the original application layer data, and it like email, like file, and then it will hand over the data to the receiving application, right? So that is how it works. And as we know, there are two transport layers available for the internet applications. One is TCP and one is UDP. Now, if we want to have a real life example, I like this book because there are so many real life examples for each concept. So if you want to differentiate between the transport layer or network layer services and protocols, you can use a real life analogy, and then you will understand network layer is a logical communication, transport layer is also a logical communication. But see the red colored keyword. Network layer is a logical communication between hosts. Every machine is identified by an IP address, right? So network layer provides the IP address. So it can only identify the host. It cannot identify application process that transport layer can identify. So you can now say network layer is a logical communication between hosts, and transport layer is a logical communication between processes. Okay? And definitely transport layer relies on, or transport layer enhances the service provided by the network layer. So in the real life example, household analogy, where it says 12 kids in Anne's house sending letters to 12 kids in Bill's house. For example, there are two buildings, maybe in two different physical places, and in each building we know there are multiple houses, and in each home or each house there are multiple kids. So those kids are exchanging letters among themselves, exchanging messages among themselves. So in this case, you can term the hosts as houses. The building is like host, is end system, and each building has multiple houses, multiple apartments, each one like a process. Or if you if you identify each kid, that is better. If you identify each apartment or flat, still there can be multiple kids, right? So they're saying that actually they means house as one single house. I think that is better to understand. And each house contains 12 kids, maybe 4 families, 5 families, or 3 families, 12 kids. Now kids are like processes. Now who is sending letters? Kids, right?
Kids.
And also who is receiving letters?
So kids.
Kids. But kids are actually resided in the house. So house is the end system, kids are like processes. So we can actually relate. Now when one kid sends letter to another kid, that means one process sending data to another process. So in that case, letters are put into envelopes. That is the application layer message. And then What is transport layer? N's house and Bill's house. So N is possibly the guardian responsible to actually hand over the letter to the particular kid. So in that case, this is the transport protocol. Maybe they are taking the letters, envelopes, and then posting in the post office, going to the post office, and the post office is carrying the letter to the destination house. Maybe it is in a different city. So postal service we can call a network layer protocol. So in this example, we can differentiate about among the hosts and processes, application messages, and who is the transport layer protocol and who is the network layer protocol. Is it clear?
Yes, sir.
স্যার পোস্টাল সার্ভিসটা কি স্যার ডাটা লিংক লেয়ারের মধ্যে পড়ে না স্যার?
Okay, good question. Actually, if you think what postal service, how postal service actually gives service, maybe there is a post office in Dhaka, there is a post office in Chittagong. So from Dhaka post office, the letters will not be carried by that post office to the Chittagong. Maybe they will hand over those letters to, for example, another place in Dhaka. Then from that place in Dhaka, it will be carried by some other entity to the Chittagong. I can call this like, sometimes it is called where the goods, the materials or the products are stored, right?
Regional
These are
office,
called-
something like.
Right, regional or station, some station where that is responsible to transfer from one place to another place. But the post office, they receive letters from the user and they actually hand over to that station or that particular agent. So see, the data link layer is from Dhaka, from the post office of the region of my area to the Dhaka Central Station. That is the data link. But our goal is not the Dhaka Central Station. Our goal is actually Chittagong, the final place. So that's why it is, if you say network layer protocol, then the postal service is an example. But again, the postal service is divided into a number of links. So postal service actually depends on services from those links, those agents. So there are data link layer, but as a whole we call this a network layer protocol, right?
Okay.
And in this chapter we are dealing with up to network layer because we are reading transport layer. So transport layer only will take data from application, transport layer will take service from network. So there is no relation with data link. That's why we are not talking about data link here. And every layer you should assume the lower layers are working fine. Definitely if data link layer does not work correctly, network layer cannot perform, right? Okay.
জি স্যার।
So how this happens in transport layer, as I said, I think in the previous chapter, we have some idea about socket. So here you can see sender in this case, in this example, sender is the server. It is sending an application layer message. It goes to transport layer. Transport layer adds a header. Actually, it creates different segments, but that is not shown here. It shows a single segment. But if application data is large, then there can be multiple tens or thousands or millions of segments. Each segment will have its own header, and then it will be handed over to network layer. Network layer will create its own header, and it will pass through the network IP, internet protocol. And then at the receiving end, network layer will hand over to a segment to the transport layer. Transport layer will remove the header and then hand over the application layer message to the application. This is how it works. Clear? This is a good animation. Now, as we said, there are two principal internet service protocols. One is TCP. In chapter 2 also we have some basic idea. Here we review the same features, like TCP is a reliable in-order delivery. TCP performs congestion control. That means whenever more data, more packet comes, then the capacity we have to control somehow. We will see this in 3.7, section 3.7. Then we have to control the flow of data from sender to receiver. If receiver's buffer overflows, then that is a problem. So flow control actually deals with the flow of data from sender to receiver so that receiver buffer will not overflow. And definitely TCP needs feedback, and whenever you need feedback, you have to establish a connection before the data transfer. So TCP also needs connection setup. Now, user datacom protocol is a very simple protocol. It's unreliable. There is no connection setup, there is no feedback, and unordered delivery. That means if the segments reach to the destination out of order, UDP will not make this order. It will just hand over to application layer as it is. It is a responsibility of the application layer to reorder the out of order segments. Why UDP does not do that? To make it simple so that it can work faster. So the main idea of UDP is to work faster. That's why it is called no frills extension of best effort IP. IP is network layer. This is called best effort. That means it will try the best to hand over the packet to the destination, but somehow if the packet is lost in the middle, network layer has no responsibility. That is the best effort IP. So it will not give any feedback. And UDP is no frills extension of this. That means UDP will add nothing on top of IP. Just still we need UDP because we need to communicate between two application processes. We need to have port numbers there, socket there. So UDP actually identifies those sockets and port numbers. That's it. UDP will add nothing on top of IP. But in both cases, there is no guarantee of minimum delay. There is no guarantee of fixed bandwidth. This is because this is packet switching. In packet switching, we are not dedicating any resource. But definitely there is a concept called quality of service. And by using quality of service parameters, we can implement some mechanisms so that the minimum bandwidth can be ensured, the minimum delay can be ensured. So there are protocols like this, but by default, both TCP UDP will not provide any guarantee about delay or bandwidth. So that is, until this point, we are not introducing any new things. We are just reviewing the concept we have already got. So the first thing, that is section 3.2. The first thing, the new thing in this chapter is multiplexing, demultiplexing. You have already heard, heard that multiplexing is what? Input many, right? And then output one, right? Is that multiplexing? Many input, one output.
One
Yes,
input,
sir.
many output.
One input, many output.
Multiplexing.
Multiplexing, many input, one output. One output. You
Yes,
have
sir.
done in digital logic. Many incoming links,
opposite is
but there is only
demultiplexing.
one. Right, opposite is demultiplexing. So in this case, we are using this term in networking. So this is not the signals like incoming signal. This is the idea is actually now related to process. As we said, in a single host, many processes can communicate, right? But there will be one transport layer. So as we saw in our previous example, real life example, there are many kids in the house, but only one, maybe n's house. So n will control sending the data to post office. So same thing, although a host can run many applications, but there is one single transport layer agent. So what will happen then? Multiple application data will be sent through the transport layer in a single logical link, right? So that is what? That is multiplexing. So at the sender, it always happens multiplexing. What happens at the receiver? The opposite. It will read, it will input data using one single logical link, but then in the receiver there are how many applications? Multiple applications, right? So the receiving transport layer will hand over the data to the correct application. So in the receiving side, it will be demultiplexing like this. You can see here. See, there are two clients and one server. So what happens? The clients, each client runs one application. It can run multiple applications also, but in this example, one application. And you can see in the server, there are two processes running. And then in this example, server is sending data to two different machines. Maybe server is sending HTTP response. So there are two web servers hosted in the same machine. So it is sending the response to each different user with different IP address. So what happens, see, in this server machine, two processes running, both sending data to transport. So that is what? Multiplexing or demultiplexing? That is multiplexing, because multiple application data is received by transport layer, and it is the responsibility of transport layer to send the data in such a way so that data will not be mixed with each other. How that is happen, we will see very soon. So multiplexing happens at the sender. In this case, server is the sender. But you can think about a client machine. Like in our machine, I can browse several websites. I can run email software. I can run Skype at the same time. So I can run many applications at the. So if my machine is the sender, also there is multiplexing happening. Now, when receiver is receiving, then receiver is receiving using a single line, but receiver must send the data to the correct application. So that is actually demultiplexing. Now see, in this example, when both client machines send a reply or send a request to the server, there are two applications. So again, transport layer will receive using the same logical link, but it must hand over segments to correct application. So this is the opposite: single input, multiple output. So that is demultiplexing. But one thing you have to keep in mind, in case of networking, always multiplexing happens at the sender, demultiplexing happens at the receiver. It cannot be opposite.
Sir, UDP te ki sir header theke sir transport header theke UDP te?
Definitely there are headers. Both TCP has headers, UDP has headers, but there are differences. We'll see. We'll
Okay,
see.
sir.
Okay, now how demultiplexing? Okay, see the common thing, irrespective of TCP, UDP, both definitely contain source port and destination port. So actually, this source port and destination port actually helps us to do multiplexing and demultiplexing. So that at the receiving end, receiving transport layer must hand over correct segment to the correct application. How? Using the destination port. So when we say how multiplexing, demultiplexing works, we need to know IP address identifies a particular host and port number identifies a particular what?
Process.
Application in a particular host. So we need both IP address and port number. So whenever you see any client code or any server code for socket programming, or if you want to establish a socket, you need to have the IP address and destination port number of the destination. So that's why these two tuples helps the receiver to direct the segment to the correct application, irrespective of TCP or UDP. Both contain source port and destination port. Okay. Okay, I think the next topic is 3.3, that is UDP. We'll start UDP in the next class. Let us finish here for today. Any question, anybody? Okay, so we have covered the basic, that is 3.1 and 3.2 today, and we'll start 3.3. in the next class, and in that part you will see, we'll go to details of the different fields of headers in UDP and TCP separately. Okay.
Okay, sir.
Okay, so let me stop here and just take a first attendance, please. Response as early as possible. Abdullah Al Rifat.
Yes, sir. Haji, sir.
Inamul Haq.
Present, sir.
Imam Reza.
Present, sir.
Rokonujjaman. Laila Ishrat. Farah Farzana. Fazle Rabbi.
Yes, sir.
Priyobroto Nath. Ifat Haq Rafsan.
Yes, sir.
Ali Ahmed Khan.
Sir, chat box is
Okay. Kaushik Devdas.
Yes, sir.
Khurshida Jahan.
Present, sir.
Okay. Samir Ahmed.
Yes, sir.
Mahmudul Hassan.
Present, sir.
Fahim Shakil.
Present, sir.
Abu Sajjad. Abu Sajjad. Okay. Nibirujjaman Nibir. Sadman Sakib. Adnan Kobir.
Yes, sir.
Taki Yasir.
Yes, sir.
Shahadat Hussain.
Yes, sir.
Rakibul Islam.
Yes, sir.
Al Shahriyar.
Yes, sir.
Tanvir Hassan.
Yes, sir.
Sakib Hussain.
Yes, sir.
Mashuke Alam.
Yes, sir.
Sabbir Sarkar.
Yes, sir.
Abrar Sadiq.
Yes, sir.
Ishtiaq Ahmed.
Sir,
Abdullah-
Mashuki Alam আছে।
Okay, present. Mashuk Alam present. Abdullah Al Mufail.
Present, sir.
Mahfuzur Rahman Sifat.
Yes, sir.
Shafiqul Islam Nirab.
Yes, sir.
Amanta Hussain. Abir Reza Pial.
ইলেকট্রিসিটি চলে গেছে।
He was present.
জি স্যার।
Okay. Khondokar Jahidul Islam.
Yes, sir.
Okay. Okay. Amanta Hussain present. Khalid Ridwan. Ali Ahmed.
Yes, sir.
Ali Ahmed. I think Ali Ahmed is already present. Okay. Khalid Ridwan.
Yes, sir.
Okay. Shahriyaz Rimon.
Present, sir.
Tahmina Tanjin.
Present, sir.
Muhammad Mahfuzur Rahman.
Yes, sir.
Fazila Nobi.
Present, sir.
Ashrafun Nahar.
Present, sir.
Shifa Chaudhuri.
Yes, sir.
Mesbahul Alam.
Yes, sir.
Yasir Arafat.
Present, sir.
Sudeep Sarkar.
Present, sir.
Abdur Rahim.
Present, sir.
Okay. Miraz Farooq.
Yes, sir.
Abu Abdullah. Khondokar Sravon.
Yes, sir.
Shah Alam.
স্যার ও ছিল স্যার নেটে সমস্যা।
Okay. Yes, Shah Alam was present. Imtiaz Hussain. Imtiaz Hussain Shobhan. Rifaz Nahian.
Sir, Imtiaz, sir.
Okay, Imtiaz. Rifaz. Kamrul Islam Tushar. Dihan Pathan.
Present, sir.
Abu Kibriya. Bidhan.
Yes, sir.
Abu Kibriya. Okay, Bidhan.
Yes, sir.
Okay. Shakhawat Hussain.
Sir, Abu Kibri.
Sir.
Okay. Abu Kibriya present, right? Yes. Shakhawat Hussain present. So anybody else?
Yes, sir.
Sir,
Laila?
Yes, sir. Present, sir. আমি দিতে পারিনি, sir.
Laila Ishrat?
Yes, sir.
Okay. Anyone else? Priyobroto. Okay. Anyone?
Sir.
Sir, Sabbir Sarkar.
Sir.
Yes. প্রিয়ব্রত প্রেজেন্ট, প্রিয়ব্রত প্রেজেন্ট, ওকে।
স্যার স্ক্রিপ্ট তো স্যার দিতে পারছি না, আমি ভার্সিটিতে এসে স্যার ট্রাই করতেছি, কিন্তু ভার্সিটিতে তো স্যার কাজ করতে পারতেছি না।
Okay, send me as early as possible. Sabbir Sarkar, you are present. Okay, thank you very much. Let us end today. See you in the next class.